Greetings and warm welcome. Dear students, we are into week 7, lecture 3. Today's topic is design of helical gears. Lecture learning outcome. Of completion of this lecture, you will be able to design the helical gear for a real-time problem. Dear students, helical gear has teeth in the form of helix around the gear. Two such gears may be used to connect two parallel shafts in place of spur gears. The helices may be right-handed on one gear and left-handed on the other. The pitch surfaces are cylindrical, as in spur gearing, but the teeth, instead of a bearing being parallel to the axis, they will wind around the cylinders helically like screws. You might have seen screws will have threads, inclination and descending, right? So helices will be at an angle of 20 degrees, 40 degrees, 15 degrees, like that. Okay. The teeth of helical gears with parallel axis have line contact. The teeth of helical gears with parallel axis have line contact, as in spur gearing. This provides gradual engagement and continuous contact of engaging the teeth. Hence, helical gears give smooth drive with high efficiency of transmission. Dear students, here is a picture which shows the pinion and gear arrangement. You can see here, right? One is right-handed, the other one is left-handed gear. So I will show you the proportions of helical gears now. So these are the different proportions of helical gears uh, recommended by American Gear Manufacturers Association, AGMA. The pressure angle will be usually 15 to 25 degrees and helix angle will be 20 to 45 degrees. And here the addendum is zero point 0.8 module, dedendum is 1 module. Minimum the value is 1 module. Okay. So minimum total depth is 1.8 module and minimum clearance is zero point 0.2 module. As we all know, module is diametral pitch to the total number of teeth. So here the thickness of teeth will be 1.5 times of module. Okay. So coming to the strength of helical gear, dear students, helical gears have contact between mating teeth. So it will be gradually starting at one end and moving along the teeth, so that at any instant of a line of contact, it runs diagonally across the teeth. Therefore, in order to find the strength of helical gears, a modified Lewis equation is being used. Here, Wt is equal to sigma naught into Cv, small b, phase width, pi into module into y dash, y prime. So y prime is tooth form factor or Lewis factor, corresponding to the formative or virtual or equivalent number of teeth. So formative, virtual or equivalent number of teeth is nothing but having drawn an elliptical cross section over the cylinder surface and taking the radius from minor axis center. So we'll going to draw that at later case. We shall discuss in the classroom. So coming to the procedure, right? We may have to proceed like this. The value of velocity factor will be taken like this for different velocities. Velocities between 5 meter per second to 10 meter per second, we'll be taking CV is equal to 6 by 6 plus V. Okay. Now, varying velocities will be taking like this. So dynamic tooth load of helical gear is given by WD is equal to WT plus this value. Okay. Where V, B, C have usual meaning as discussed in spur gears. Okay, velocity factor, uh, correction factor, phase width. Okay, WS static tooth load and WW maximum limiting wear load. So these are all the values that are necessary to design an helical gear, almost similar to the spur gear. Okay, we have seen this in spur gear. So here is a reflection spot to test your knowledge on previous topics that we have covered. Okay, identify and state the difference between the following two. So here are two pictures given. Kindly take some time, identify these two. I will give you 15 seconds of time. Identify the things. So your 15 seconds of time is up, dear students. I hope you could able to recognize what it is. Otherwise, you may have to go and refer the classification of gears and the nomenclature. Okay. If there is a groove between two helical gears, that is called as double helical gear. Without a groove, it is called as herringbone gear. Herring is a fish and it is a herringbone gear, a fish bone type of gear. Okay, it will have fish bone type of teeth. So double helical gears are cut on a single gear blank by a hob with a tool run out groove between and the hands of helices. Okay, the herringbone gear is cut by two cutters which reciprocate 180 degrees. One gear will be one cutter will cut over here and at 180 degrees will cut another face to avoid clashing. Okay, whereas double helical gears cut on a single gear blank by a hob with a tool run out. That's why this gap is being provided. The cutting chips will run out from this area. This is called double helical. This one is herringbone helical gear. Okay, herringbone and double helical gears offer the following advantages. So coming to the first advantage is that they develop opposite thrust reactions. So one thrust force will act like this. So another thrust force will push inside. So net axial force will be zero on the bearing. So bearing will be safe. The power transmitting capacity may be higher because of this less axial or net axial force is zero. Okay, reaction forces will coincides so that net axial force will be zero and high pitch line velocities can be attained. We can go for high speeds and we can go for heavy turning movements like in hoisters, uh, elevators and cranes. So coming to the outcome, upon completion of this lecture, you will be able to design the helical gear for a real time problem. So I hope everything is clear. Thank you all. Have a happy learning. So herewith I am closing my session. Thank you so much.